So keeping an eye on that. Yeah, we're just live on our YouTube live stream now. So welcome to folk that are watching us via the wonderful technology of YouTube. Who owns YouTube now? Is it
Google?
Google, Alphabet.
Yeah.
What they're called. Yeah, well, very welcome. I'm just going to say hi, welcome. We're going to get going around about past, so we'll give it another few minutes for people to join. In the meantime, I can sit back and watch the clouds sort of slowly drift across the sky. There's Mr. Liner.
There you all are. Hello, everybody.
Eddie, hi. Eddie, hi.
Hi, Andrew.
Hi.
Do you know what type of clouds they are, Liz?
Yeah, they're moist ones. No, I'm not a cloud spotter really. They're very high up, these ones. So
Edna. They're Edna.
Edna
Clouds.
Oh dear. Oh dear.
You weren't paying attention to Nick Shemanik's talk.
No, I never pay attention to Nick Shemanik's talks. No. Is he on? Oh no, he's not. Oh dear. No, I do. Yeah. You'd think of somebody that likes looking for clear skies. I would pay attention to the weather, but I tend to rely on the apps now. And then if it says it's cloudy, I always go out and have a look. And if it's clear, I'll set up or just open up. So sometimes these forecasts, you know, it's a bit like if you had five weather forecasters in a room, you know, you'd probably get 10 different forecasts. Oh, anyway.
Well, you don't need to go out tonight, Les. It's definitely cloudy.
Well, yeah, except it's clearing, I think.
It's nice and blue where I am.
Yeah. Oh,
Yeah.
right. Okay.
Clear in Basildon.
Yeah.
Clear I am in Basildon, so.
Oh.
Yeah, but
Living in the wrong place then.
look to the west, Andrew.
I am, there's no clouds.
Yeah, I'm looking east.
Yeah,
I'm
if you
looking
look west, it's really cloudy, and that's where the clouds are coming from.
Yeah.
Oh, well.
It's clear here.
Ah, well, that's
Down
the
in
other side of the
Somerset.
world.
Well,
Down west, that's the other side of the world.
Yeah.
your clouds, Roger, will come to us eventually because we got northwest winds at the moment.
Oh, right. The polar vortex.
There we go. Brilliant. Right, how are we doing? We've got folk here. Folk on live stream on YouTube. Excellent. Right. Where's Liz? Liz not here? No, she may be working, I guess. How you doing, Emma?
All right.
Yeah, nice and quiet there. Have you sorted your laptop out yet, or you?
It's getting there.
It's getting there, is it? Oh, good.
Still like this, isn't it?
Yeah.
Hey, man.
You want to go in landscape mode like that?
Oh, no, it will be. Hopefully next meeting.
Okay. Just whilst or just before we kick off, and then I'll hand over to our chair, Les Jones. Just the normal housekeeping for our WebEx users, at least. If whilst our speaker tonight is talking and is giving her talk, if you could all make sure you go on mute, and actually it also helps if you can just temporarily at least switch off your video, because then that automatically spots light Affelia when she's talking. It just helps to reduce any distractions. And if you've got any questions, make sure to type them in the chat, and then we'll cover those off at the end. And as usual, we've got the whole sort of session open until around about 9:30. So after our speakers finished, everybody's more than welcome to stay on, and we'll just have a general chat as on any topics, hopefully astro related. We've got certain topics that are banned. I'm not going to mention the C word, but that's banned. So I think
J word.
Sorry?
The J word.
Yeah, the J word, that's banned as well. Yeah. Okay. And any other words that we can think of in the meantime, they're all banned. But the only words that we want to hear are the words of, first of all, Les Jones, and secondly, Affelia. So I think it's, according to my clock, it's 7:30. If I hand over to Les to take us through the proceedings.
Okay, fine. Thanks, Liz. Can you all hear me there? Yeah? Okay, right. Okay, then. Well, hello, everyone, and welcome to another online meeting of the Havering Astronomical Society. It's nice to see you all again this evening. I notice we've got a couple of new members of the Society with us here, so special welcome to you. I'm sure that over the few coming months that we'll have a lot to offer you and anyone with an interest in astronomy. Our speaker this evening is Affelia Wibisono, who is a PhD student in the Planetary Science group at UCL's Mullard Space Science Laboratory. She completed her Master in Science Physics degree at the Royal Holloway, University of London in 2012. And she then went on to have a career in science communication at the Science Museum and at the Royal Observatory Greenwich. She started her PhD at the Mullard Space Science Laboratory in 2018 and is working on Jupiter's aurorae with observations from the Hubble Space Telescope and the Juno and the XMM-Newton space missions. Now, I understand that apart from the studies, her hobbies include playing football, collecting an absurd number of cacti and succulents, and making a lot of noise on her drum kit. Aphelia's talk this evening is entitled Seeing Jupiter's Aurora in a Different Light, where she'll discuss how we can use what we know about our giant neighbour to better understand how more exotic objects produce X-rays and even help us to discover potentially habitable exoplanets. So without any more from me, I'd like to hand over to Affelia.
Great, thank you very much. Yeah, I kind of forgot I gave you those info about me, but they're correct. So yeah, I'm just gonna share my screen. Need to remember to optimize for video. Excellent. There. Can you see my screen?
Yes, it's clear.
Excellent. Cool. So yeah, like Leslie said, I'm a PhD student. I'm sort of 11 months, I've got 11 months left on my PhD, which is kind of scary. And my research focuses on Jupiter's X-ray aurora, and yeah, I use data from XMM-Newton mostly, but because of, Juno, I use quite a lot of Juno data as well, because it kind of, helps us, it gives us context to what's happening at Jupiter. So let's start off firstly with the Earth's aurora. You've probably seen lots of pictures and videos of the Earth's aurora. They look like this shimmering, dancing curtain of light. And our ancestors have been marveling at the Earth's aurora for millennia. I think the oldest recorded, recording of an auroral sighting is a 30,000-year-old cave painting. So that's pretty amazing. And to understand where the Earth gets its aurora, we need to start off with the Sun. The Sun releases a constant stream of charged particles in the solar wind, and that goes out to the solar system. And of course, occasionally the Sun can release a lot more matter in coronal mass ejections. The solar wind can meet obstacles along the way, like the Earth's magnetic field here. Some of the charged particles from the sun can sort of get funneled into the Earth's north and south poles, but most of them get deflected around the Earth and sort of behind the Earth. And then later on, they get shot back towards the planets, and that can make the aurora brighter and more active as well. So our atmosphere is made up mostly of nitrogen and oxygen gas. What happens then is these solar wind particles excite the atoms or molecules in our atmosphere. They get energized, they get excited, or the electrons get excited, and then later on, when the electrons release that energy back out, they do it in the form of light, and we get different colors from the different gases in our atmosphere. So cameras are pretty good at picking up the subtle colors, and we get the red aurora, for example, from high altitude oxygen. Green comes from oxygen again, but from lower down in the atmosphere. The bluish purpley color comes from low-lying nitrogen, and you can get a mixture of these colors to give pinks and yellows as well. And this picture here on the bottom is what the aurora looks like from space, and you can see how the colors kind of change with height as well there. But I bet our ancestors would have, they wouldn't have had any idea that the same phenomena can happen at other places. So here are some examples of extraterrestrial aurora. The first planet here is actually Mars, and even though Mars doesn't have a global magnetic field as such, it has sort of localized magnetism. So some of the rocks are magnetic, and they can actually sort of capture those solar wind particles, and then they energize the atmosphere, or very thin atmosphere around Mars, giving us sort of very localized aurora. Of course, we're going to talk about Jupiter later on, but Jupiter's moon, Ganymede, also has aurora. It's the only moon that we know of that has its own magnetic field and has its own aurora. So generally, for a planet or an object to have an aurora, it needs a magnetic field. And Saturn has bright aurora too, and this is Uranus. So all of these are actually in the ultraviolet wavelength, and where Uranus's aurora, where we can see them there, it might be sort of different to where you expected it to be, but of course Uranus's tilt is, it's very sort of it's not like the other planets. It rolls around on its side, and its magnetic rotation is offset from its rotation sort of axis. So where the aurora is, that's actually where Uranus's poles are. And actually, for many decades, we lost Uranus's poles. So it was first discovered when Voyager 2 made its flyby, and then for many decades we didn't know where the poles were, the magnetic poles were, and then when the aurora was seen again, that's when we found the poles again. So we talked about the different colors and the Earth's aurora. So visible light or white light is made up of all of these colors in the rainbow, but of course visible light is only a small part of the electromagnetic spectrum, which ranges from gamma rays to radio waves. The wavelengths get longer as you head towards the radio end of the spectrum, and the energy gets lower as well, and this is the only part of the spectrum that our eyes can see. But of course, now we've got telescopes and detectors and things, so we can detect every single part of this spectrum. Jupiter's aurora is quite unique because its aurora covers most of the electromagnetic spectrum. So you've got the X-ray aurora, the ultraviolet aurora, visible light or visible aurora, infrared, and radio. So I'll talk a bit about how the X-ray aurora produced a bit later, but the ultraviolet aurora are produced in a very, very similar way to how the Earth's visible light aurora gets produced. So charged particles rain onto the atmosphere at the poles, and then they excite the hydrogen atoms and molecules in Jupiter's atmosphere. And the visible aurora is actually the dimmest part of the of Jupiter's aurora. You can only see it in the nighttime side. So this picture was taken by Galileo, the Galileo spacecraft, of course, and it only saw it when it only saw the aurora when it was in the night side of Jupiter, because otherwise this just gets lost in the sunlight. The infrared aurora comes from those charged particles heating up certain sort of molecules in the atmosphere, and the radio waves come from electrons. So they get sort of pulled in by the magnetic field, they spiral, and when they spiral, they give off radio waves. So I can't talk about the aurora without talking about the magnetosphere. So a magnetosphere is like a magnetic bubble around a planet. It's kind of like an invisible force field, which kind of protects the planet from the solar wind. So this is just a size comparison with the Earth's magnetosphere here. You can fit pretty much, well, most of the Earth's magnetosphere sort of inside Jupiter. That's kind of a very generalized comment, because what we call the magnetotail, we don't actually know how far the Earth's magnetotail goes out to. It's very sort of tenuous, so it's hard to sort of say where it ends. But you can see it's much smaller than Jupiter's. Jupiter's magnetotail, by the way, extends out to the orbit of Saturn, so 5 astronomical units away. And this is the largest coherent structure in the solar system. So it's larger than the sun. And if we could, if we have like special magnetosphere goggles that lets us see Jupiter's magnetosphere, it will be a several times the size of the full moon. That's how large it is. And there's loads of what we call plasma inside this magnetosphere as well. So these are these charged particles, and the sort of energies involved in Jupiter's magnetosphere, the speed that these charged particles are moving at are incredibly high, much higher than what we find here on the Earth. So yeah, the magnetopause is kind of the boundary between Jupiter's magnetosphere and the solar wind, and the bow shot is you find lots of sort of shot solar wind particles here. Yeah, and then sort of what's kind of really different about Jupiter's magnetosphere is that all of these black lines are the magnetic fields of Jupiter. So you might remember from school, you know, when you draw the magnetic field around a bar magnet, so it's like that butterfly diagram. The Earth is very much like that diagram, but Jupiter, as you can see, the ones that are sort of quite close to Jupiter are stretched out. They're not sort of nice and round, and that's because of what we call the Io plasma torus. And I'll talk about Io a bit later, because Io is actually very, very important for Jupiter's aurora. So even though my focus is on the X-ray aurora, the ultraviolet aurora, it's actually quite useful for me. there are a lot of connections between them, and we can actually use the UV aurora here to tell us what the solar wind is doing. So the solar wind can sometimes be, you can get a sort of a big gust of solar wind, which pushes on Jupiter's magnetosphere, and that makes the aurora brighter, for example. And the UV aurora sort of reacts to that solar wind, and it produces different features. So what we're looking at here, this is a video by the Hubble Space Telescope. You've got the main auroral oval here, just like the Earth's. And then within that oval are polar emissions. So this is different to the Earth. At the Earth, we don't get a lot of emissions at the poles. We get a lot sort of in the ring, but not at the poles. And something else that's different is this spot here, and actually that spot there. So these are satellite footprints. So this one would be from Io. I think that's another one actually. Those would be from Ganymede and Europa. So when these moons are orbiting around Jupiter, they disturb the plasma that's around the planet, and cause some of them to sort of rain down onto Jupiter and produce these features. We haven't seen Callisto's footprint yet because we think it's kind of embedded within this main oval, so it's probably being drowned out by all of this emission. So we now know that there are sort of 6 main categories you could put the UV aurora in. And again, this depends on what the solar wind is doing, depends on sort of the conditions around Jupiter at the time. So you can have a main oval that's quite diffuse and quite dim. You can have sort of bright flares in the polar emissions, or the main oval can narrow, or you can get sort of very localized short-lived brightenings here, sort of in the dawn side of the main oval, and then you can have this sort of quite strange angular feature in the dust side, or you can again have sort of arcs within the polar emissions as well. So these are sort of the names for these groups. So we think when the aurora is doing this, there's not a lot going on. The solar wind is very sort of gentle. When it's unsettled, or there might be something happening there, the solar wind could be picking up in strength. And then when this happens, that's definitely the magnetosphere of Jupiter is definitely being squashed by the solar wind. So I use this to kind of put my work into context. Because if we know what the conditions are around Jupiter, then we can kind of connect what the X-rays are doing, and kind of, I guess, do a similar thing for the UV aurora. So we could say, if the X-rays are bright, then we think the solar wind is doing this. But yeah, and of course, Juno is still in orbit around Jupiter, and it has the UVIS instrument, so it's a UV camera, and it orbits Jupiter in this sort of polar orbit. So it sort of dives down to the North Pole, comes out sort of below the South Pole, and the time it takes for Juno to go from the North Pole to the South Pole is a couple of hours. So it's really whizzing around, and this is what Juno would see during its approach, and sort of when it sort of moves away from Jupiter again. So these are real images of the northern and southern aurora there. We just kind of put it on this on this globe of Jupiter. But yeah, I mean, I would really love to be able to see this with my own eyes. Imagine if sometime in the future our descendants can go in a rocket ship and see Jupiter's aurora for real. I think that would be pretty cool. But onto the X-ray aurora. So it was actually first discovered in 1979. The first extra-terrestrial aurora discovered was Jupiter's ultraviolet aurora, again in 1979. That was discovered by Voyager 2. And then a few months later, the Einstein Observatory discovered the X-ray aurora. And this is one of the first images of Jupiter in X-rays. So it's not a lot to go on. There's some stuff here. So this orange circle there is where Jupiter was at the time, and then you can see some emissions coming out from the poles. And then in the 1990s, we had the Rosat satellite. So it had a better spatial resolution, so you can see a bit more clearly what you're looking at. So again, this white circle is Jupiter. You've got the northern aurora here and the southern aurora at the bottom. So you can see the northern aurora is much brighter than the south. And we can now see that actually there are some X-ray emissions from Jupiter's equator as well. And then in 1999, we had Chandra and XMM-Newton launched. So these two telescopes are good at different things. The Chandra telescope has much better spatial resolution, so it can sort of pinpoint where these X-rays are coming from. So you've got a very nice sort of circle here where Jupiter is. You can very clearly see where the northern and the southern aurora is. All of this stuff here, from sort of the lower latitudes where the equator is, below, sort of, in between the two aurora, this is just the sun's X-rays bouncing off Jupiter's atmosphere. So Jupiter acts like a mirror and reflects solar X-rays back towards us. Now, XMM-Newton has a rubbish special resolution. You can see the difference between the two images here. So the green circle here, that's Jupiter. This is the northern aurora. This is the southern aurora, and this is where the equator was. And the aurora in the XMM pictures seem to sort of spill out over Jupiter, and that's because XMM's pictures are blurred because its mirrors aren't as good as Chandra's. So that's why XMM takes rubbish pictures, but it's got very good spectral resolution, so we can measure these the energies of these X-rays very, very well, and that's it's very useful actually. And I just wanted to say we've got the dates of when these satellites were in operation. So at the moment, Chandra is has funding secured until the year 2024. There's a possibility that it could go on until 2030. And for XMM-Newton, it's got definite funding for 2022, but there's a possible extension for 2025. So hopefully we've got these telescopes for a few more years yet. And using Chandra data, we can actually make a map of the X-ray aurora. So these are sort of polar projections. So it's as if we were looking down at Jupiter's North Pole here and South Pole. So you've got sort of the brightness here. So where you see red, that's where the aurora is very, very bright. So again, you can see that the northern aurora is much brighter than the southern aurora. And there are a few different reasons for why that could be. It could just be a viewing sort of angle reason, just because of how Jupiter is tilted, we can see more of the North Pole usually, and the northern aurora is also offset from the pole slightly more than the southern aurora, so we can see more of it, so it just looks brighter. Or we know that the magnetic field of Jupiter is very bumpy, so they're very different at the North Pole and the South Pole. The strengths are very different. So that would play a role into, how much of these charged particles can enter the atmosphere over the North Pole and the South Pole. But again, you can see actually their shapes are different too. So at the north, it's more of a kidney bean shape, whereas for the south, it's more of an oval. And again, one of the possible reasons for this sort of kidney bean shape is the shape of the magnetic field. There might be like a little anomaly here in the magnetic field, which kind of pushes the aurora oval sort of in this part. So how do we get these X-rays? So what we've got here in this picture are actually data from Chandra. So the green dots, they're X-rays detected by Chandra, and the orange is the UV aurora picture taken by Hubble. So these observations were taken at the same time. The small dots are low energy X-rays, and the big dots are high energy X-rays. And you can see that most of the high energy X-rays coincide with where the UV aurora is. And that's because the high energy X-rays and the UV aurora are caused by the same population of energetic electrons. Whereas the low energy X-rays are from ions or positively charged atoms. So we get the soft or the low energy aurora from something called charge exchange, and the electrons from Bremsstrahlung radiation. So what are these words? So charge exchange happens when you've got an ion, for example, this thing here. So this atom has lost some of its electrons, so it's positively charged. It gets close to a hydrogen sort of atom or molecule in Jupiter's atmosphere. The ion steals an electron from that atom or molecule. And so now this captured electron, which is this thing here, is all excited. It's got this extra energy. And then later on, it will de-excite and release an X-ray photon, sort of, X-ray light that comes out. So that gives off low energy X-rays. This process is called charge exchange. For electrons, they're again sort of being accelerated into Jupiter's atmosphere, but then they get slowed down by all of the atoms or molecules in the atmosphere. And when electrons slow down, they give off high energy X-rays. So in old style TVs with the cathode ray tubes, you've got Bremsstrahlung radiation sort of being given off there, and also in particle accelerators as well, you get Bremsstrahlung radiation coming off those electrons. So that produces the high energy X-rays. So this is what makes the X-ray aurora different. So actually two things. One, they're released by the particles coming in, whereas the other aurora are produced by Jupiter's atmosphere itself. And two, they're produced by ions and electrons, whereas the others are only produced by the electrons. So the X-ray aurora is slightly different to the others, and I think slightly more useful because it can tell you what the electrons and the ions are doing rather than just one of those. So we've got a little sort of video here of Jupiter's aurora, or X-ray aurora, again taken by Chandra. So you've got Jupiter here spinning, rotating, and then you can see the northern and the southern aurora rotate in and out of view. So these aurora are fixed on Jupiter's frame, and they're a bit like a lighthouse or a pulsar. They're giving off these beams of X-rays, and we can only see them, we can only detect them when they're facing us. And the plot on the right here is a light curve. So the blue plot is for the northern aurora, south is the orange one. So this just tells you how bright the aurora appears to us. So you can see the northern aurora here come into view, and then when it's straight sort of in our line of sight, it appears to be very bright, and then when it starts to spin out of view, it gets dim, and then at this point we can't see the aurora because it's on the other side, and then it starts again. So you might be able to see Jupiter's sort of 10-ish hour-long rotation, especially within the blue light curve here. The southern aurora does the same thing, but again, because of that viewing angle, it's a bit more difficult to see the rotation period of Jupiter, but you've got the same kind of thing happening as well. And if you look within sort of this 10-hour-long envelope, you might be able to see that sometimes the aurora is sort of pulsing. You've got like a blip, 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 and then other times it acts a bit more erratic. So the pulsing kind of stops here, it's not pulsing here, and then it's pulsing again. And we're still not entirely sure why that is. We think it's to do with lots of different waves that you find in the magnetosphere. So these waves can literally excite the magnetic field. So one idea is that the solar wind comes in, rings Jupiter's magnetosphere like a bell, so it's literally vibrating, and that the vibrating magnetic field accelerates the particles into the atmosphere at a set frequency, and so that's why the aurora is pulsing, or at least why we think they're pulsing. And we've recently seen that it's not just the X-ray aurora that are pulsing. The UV aurora pulse at the same time as the X-rays. So the video, so the sort of blue video is again the UV aurora, and the white dots are the X-ray photons. And when you can see the sort of the red blob there, that's when the polar emission in the UV gets brighter. And you can see when that happens, there's quite a lot of X-rays as well happening there, or appearing there. So yeah, so the two aurora are sort of quite closely linked. So I mentioned Io earlier, and Io is really important for Jupiter's aurora. Not just the X-rays, but I think for the other wave bands as well. So Io is the most volcanic body in the solar system. It has hundreds of active volcanoes on its surface, looks like a moldy pizza, and you can see one of those eruptions here. So I think this eruption was about 300 kilometers high. That's how far it reached. And I think if we could sort of replace our moon with Io, and it still had these volcanoes, we'd be able to see this eruption through a pale binoculars. So they're quite substantial. And every second, Io's volcanoes releases 1,000 kilograms of material out into Jupiter's environment. But why is it so volcanic? Tidal forces. So it's kind of in the middle of this tug of war between Jupiter and some of the other Galilean moons, the 4 biggest moons of Jupiter. It's got this sort of resonant orbit with Ganymede and Europa. So this is what tidal forces, this is how you get these tidal forces. So because Io's orbit is not perfectly circular, it's sort of this elliptical shape. Sometimes it'll be slightly closer to Jupiter than other times. And then you've got a difference in forces or gravitational sort of forces from Jupiter on sort of opposite sides of Io, and that heats up its insides, and that's why it's got lots of volcanoes on its surface. But we actually think that all of this volcanic material released by Io is where most of these particles that produce the aurora come from. So all of those ions and electrons that are being accelerated into Jupiter's north and south poles, most of them come from ice volcanoes. So if somehow the sun were to disappear, or it had stopped giving off this solar wind, Jupiter have its aurora, pumping out all of this material out into sort of its surroundings. Our aurora would disappear, but Jupiter's will keep going. And that is fairly unique. So Saturn has a very similar thing happening. It has Enceladus, which has these geysers that spews out water and ice and things, but it's not giving off as much material as Io. So the rate is much smaller, and so I think Saturn's aurora would probably disappear if the sun disappeared. I don't think it'll be enough for Enceladus to keep Saturn's aurora going. And sort of moving further away, we've kind of I think detected the aurora from exoplanets and brown dwarfs. So brown dwarfs are sometimes called failed stars. They're kind of in between stars but sort of the lowest mass stars and the biggest planets. And in 2015, I think it was, astronomers discovered that this brown dwarf LSRJ, etc., is giving off radio waves. So actually, we've discovered lots of brown dwarfs that are giving off radio waves. That's not the important bit, but the important bit is that these radio waves are pulsing, like Jupiter's aurora. And actually, Jupiter's radio emissions also pulse, and they also pulse, generally pulse at the same sort of frequency as the X-ray aurora. And when they looked at this brown dwarf, they used visible sort of optical telescopes as well. They saw it pulsing too, and hopefully can I play this video? There, so you can see it pulsing there. They know that this brown dwarf has a rotation period of almost 3 hours, and the radio waves are pulsing, every 3 hours or so. Same with the optical. So these radio waves are coming from a sort of very sort of particular part of the brown dwarf, and their sort of idea as to how this brown dwarf is giving us these radio waves is that maybe there's a planet moving or orbiting around it, which is disturbing sort of the plasma or the magnetosphere around this brown dwarf, because brown dwarfs also has a magnetic field, or it could have a volcanic planet around it, so similar to Io and Jupiter. And then a few years later, they found another brown dwarf doing a very similar thing called SIMP J01 and so on. And I think this is what's quite important about, Jupiter's aurora, is that what we learn from Jupiter, we can apply to exoplanets, because Jupiter has, people tend to think of exoplanets to be more like Jupiter than, for example, like the Earth. It's kind of like the archetypal exoplanet. It's like an example of what an exoplanet might be like. And so we think the same or very similar processes are happening around Jupiter to produce its aurora with what's happening at exoplanets. And for an exoplanet to have an aurora, or for any planet to have an aurora, it must have a magnetic field, and we think a magnetic field is very important for life to be able to survive on an exoplanet, because the magnetic field produces the magnetosphere, which protects it from the star's sort of harmful radiation and the stellar wind, and so on. But that's, you know, very early days. So Jupiter is not the only source of X-rays in the solar system. When people talk about cosmic X-rays, they tend to think of like really big, massive, violent stuff, like growing black holes and supernova and stuff. But there are quite a lot of things in our solar system that also give off X-rays. Of course, the sun gives off X-rays. So you can see flaring active regions from the sun here. This is a composite image. So you've got high energy X-rays from new star or discovered or detected by new star. Those are shown in blue. And then the low energy X-rays were detected by the Hubble spacecraft. They're in green. And then we've got the SDO image, the yellow and the red showing the extreme ultraviolet light from the sun. But actually, one of the first, I guess, known sources of X-rays in our solar system come from comets. So you can see an optical image here of comet Ison, and then you've got an X-ray image as well. So this is when they kind of discovered how important charge exchange is in astrophysics, or at least in solar system science, because it's the same process happening here at comets as what you find in the in Jupiter's aurora. So the particles from the sun, the ions from the sun excite the gas and the molecules in the coma of the comet, and then they give off these X-rays. Moving on, Saturn gives us X-rays, so it reflects solar X-rays just like Jupiter, but its rings also fluoresce in X-rays as well. Very recently, just last month, my team and I released a paper, and we discovered X-rays coming from Uranus for the first time. So we think most of the X-rays will be again reflected solar X-rays, but we detected more X-rays than we should if Uranus was just reflecting solar X-rays. And so the rest might be coming from aurora, or it might be coming from the rings, which are fluorescing, just like Saturn. And down here, you've got Io and Europa. So they're fluorescing in X-ray. So all of the charged particles around Jupiter, they bombard these moons, making their rocks fluoresce. And actually, fluorescence is very important throughout the solar system, because the rocks on the moon, on Mars, and Pluto fluoresce. So actually, funny story, we detected 5 photons from Uranus, which might not sound a lot, but for Pluto, I think they detected 3. So you know, these are very small, very low signal discoveries, but I think it's still pretty exciting. For Venus, most of the X-rays come from scattering of its atmosphere, so rather and fluorescing from the rather than rock. And then more source of X-ray to talk about, and that's the Earth's X-ray aurora. We started off with the Earth's aurora. We're going to end on the Earth's aurora. So the Earth also has X-ray aurora. Jupiter and the Earth are the only 2 planets that we know of for sure that has X-ray aurora. We've tried looking for them at Saturn for about 20 years now. We still haven't found them, but they're here at the Earth. So the Earth's aurora comes from the Bremsstrahlung radiation. So these are produced by the electrons slowing down. We don't get the low energy X-rays from the ions, just because there's not enough energy to make these charged particles accelerate. They're not traveling fast enough to lose their electrons, to lose enough electrons to produce the X-rays. So I think this was actually an accidental video taken by Integral. I think what Integral was trying to do was observe something in the background, and then the Earth kind of photobombed and got in the way. But then we managed to see the Earth's aurora, so that's I think that's a nice surprise there. And finally, the SMILE mission. So this is a new mission that is due to launch in 2024 now, I think. It's been delayed because of the C word. And it's actually led, or partly led, by MSSL. So this is a joint mission between the European Space Agency and the Chinese Academy of Sciences. And SMILE stands for Solar Wind Magnetosphere Ionosphere Link Explorer. What it's going to do is it's going to orbit sort of quite far away from the Earth. It's going to have a very similar orbit to Juno, actually, at Jupiter. It's going to get very far away from the Earth, and then it's going to sort of zoom down towards the North Pole, and then out of the South Pole. So most of the time, apart from when it's sort of going below the South Pole, it's going to be looking at the Earth's ultraviolet aurora. So it's got an ultraviolet camera that's going to take pictures and videos of the Earth's aurora. But then at the same time, it's got an X-ray detector that's going to look at the Earth's magnetic pole, so that boundary between the Earth's magnetosphere and the solar wind, because we expect a lot of X-rays to come out from that. And that's where the logo comes from. So you've got the northern and the southern aurora here, and then the Earth's magnetic pole is a little bit like a smile. So that is due to launch in 2024. And it's going to be the first mission to have a global view of the northern aurora and the magnetic poles as well. So hopefully, we can learn more about what happens at the Earth. And then my sort of hope, my dream, is that we have a similar spacecraft at Jupiter, say, and yeah, we'll have a SMILE 2.0 at Jupiter, maybe, hopefully, in the future. But that's all I have to say for now. Thank you very much for listening and for inviting me. Yeah, I see we've got some questions, so should we try and answer all your questions?
Oh, that's great. Thanks very much, Affelia, for such a fascinating talk. I don't think in all of the years that I've been a member, and I know some other members have been members for even longer, that we've ever had a talk like this on aurora on other planets in the solar system. So thanks very much for such an interesting talk. And I think if everybody could unmute themselves and show our appreciation in the normal way.
Thank you very much.
No, thank you. You're able to stay for a little while just to perhaps answer a few of the questions that we've got?
Yeah, of course, yeah.
Excellent, excellent. Because I see we do have a few that came through, and sometimes we have other questions that sneak in as well as we go through. So let me start with the first question. You may have answered it in the slide, but the last slide but one. Can we see the Earth's aurora in different wavelengths?
Yeah. So ultraviolet and X-rays as well as visible.
Okay. And is the solar wind at Jupiter weaker than at Earth?
Yeah, so it'll be more rarefied as well. Yeah. The density of the particles coming from the solar wind will be much lower than it is at the Earth.
Okay, so there's no sort of directional effect or anything, I guess.
So as the sun rotates, the solar wind sort of rotates with it, like a ballerina skirt. And so sometimes you can get a build-up if, for example, you've got two of the swirls sort of hitting each other. Then that can produce sort of an area of of high density, and yes, that can sometimes hit Jupiter. But the problem is we don't have an upstream sort of monitoring system that tells us what's happening at Jupiter. So what the solar wind is doing at Jupiter. We've got lots of that at the Earth because, of course, it's important for space weather to protect our satellites and so on. But we don't have that at Jupiter. We have to use models.
Okay. So how is the magnetosphere measured when you gave that wonderful diagram showing around Jupiter? And how do we know that it's so large?
We know it must be large because of how strong Jupiter's magnetic field is. So that determines the size of the magnetosphere. We've had, of course, Juno and Galileo orbiting around Jupiter. We've had the Voyagers flybys, Ulysses as well, and Cassini flying by. And they can measure the charged particles around Jupiter, so they can tell if they're measuring the solar wind or Jupiter's magnetosphere. And that's how they know. Yeah.
Okay, great. Are the aurorae effects solely due to the interplay of solar wind and magnetosphere, or also influenced by high intensity atmospheric turbulence that we would see in Jupiter? And if so, what gases are mainly excited in Jupiter's atmosphere?
I don't think atmospheric turbulence plays a role in the aurora. If it does, then it will be very, very small. So the gases would be mostly hydrogen, atomic and molecular hydrogen. Yeah, and Io plays a big part as well in Jupiter's aurora. So, for example, if Io has been particularly active, then that can make the aurora brighter as well.
Okay. Why do they think Jupiter's north pole is more active than the south?
Yeah, so this is the question. We think maybe the magnetic field is stronger at north, so it can accelerate these particles, much better. These particles are traveling at high speeds, which makes the aurora brighter. Yeah, I think that's probably the reason.
Okay. Is the mass from eruptions on Io gravitationally lost to Jupiter, or does it fall back down to the moon? And if it's lost to Jupiter, then is there a projection as to how long the moon will last?
Yeah, I think some of the material will fall back down on the moon. I don't know what the sort of percentage is. But yeah, I think a lot of it does sort of get lost. So out of the 1,000 kilograms per second that gets erupted, about half of that can be sort of accelerated into Jupiter's atmosphere. But that doesn't happen straight away. It takes about 2 weeks for that volcanic material to end up in Jupiter's atmosphere.
Wow.
As a projection, I don't know. I mean, yeah, I use about the size of the moon, so I don't know how long it runs.
Brilliant. Okay. And the last question: will you continue to study X-ray aurora after receiving your PhD? And if so, what would be the aspects that you'll be studying next?
I don't know at the moment. I have no idea what I'm doing past March next year, which is quite scary. I'm looking for, postdoc positions and funding and things. But yeah, I would like to stay on to study the X-ray aurora. And actually, on Monday, I managed to get time on XMM to look at Jupiter's aurora. So that will happen Monday, Tuesday, and Wednesday of next week. And I hope that I can analyze that data one day. So I guess that will be my next project if I can continue to do it.
Brilliant, brilliant, excellent. Well, look, thanks very much for staying on and answering those questions. That's the end of the questions we've had posted. I don't know if anybody live has got any further questions, and no, nobody's shouting out. So I think once again, if we can just express our thanks to Affelia for such a stimulating talk this evening. Brilliant, brilliant. I'm going to just hand back to Les now, and I guess Affelia, you're more than welcome to stay for as long as you want. I think we just sort of have a few notices and things, and then have a general chat. Or if you want to drop off, that's entirely up to you as well. But thanks very much for staying.
No problem. I'll leave you to it. Yeah, but thank you again.
Great. Thanks, Affelia. Bye-bye. Les.
Right. Am I muted? Yeah. Okay. Fine. Right. Just very briefly, just to bring to your attention that our next meeting is on Wednesday, the 19th of May. And that's a return visit from Roger O'Brien, who's a regular speaker to us at the Society, and he spoke to us on the WebEx last year. The talk he's given us this time is on the James Webb Telescope, which is apparently on track for a Halloween launch. I don't know if there's any inference in Halloween, but that'd be interesting to hear from Roger, I'm sure. Again, as always, whilst we're still going through the hopefully final throes of the lockdown, whatever, there are still things we can do, and you've got plenty of information on the website and the newsletter. The activities, as you just say, was Peter Morris's Objects of the Month and Martin's Monthly Challenge. Been quite a lot of activity on the WhatsApp observing groups, and wonderful images over the last few weeks. And Les and Bill had a trip out east and put some stuff on there they had out. So yeah, by all means, there's plenty of stuff to look on the website, and obviously the Facebook page as well. We had a meeting last week with the young astronomers, and I must admit, I can't remember the next date the next one is, but I'm sure it'll be on the website somewhere. And if you have anybody in mind, and we're getting a fair gathering coming along now, so invite them along. And that's it for me at the moment, Les. Anything else?
No, excellent. Thanks, Les. And Les, you're being a little bit modest there, because Les was our speaker for the young astronomers meeting last week, and he had them enthralled with part one of the solar system, with the sun and the inner rocky planets. So yeah, it went down very well, I think. Yeah. So and Peter gave his a slightly different version of his Sky talk to the young astronomers, which again went very well. And we gave them a few items of the space news, which, as you can imagine, was pretty much focused around things like perseverance and, in particular, ingenuity. And what else did we cover? Oh, one or two.
SpaceX and whatever, yeah.
Oh, SpaceX launch, that was it, yeah, and the arrival at the ISS. So yeah, it's great. And but yeah, a shout out to anybody who would be interested in giving a talk aimed at that sort of 8 to 10 to 12 to 14-year-olds. I think there's a sort of reasonably broad spectrum. So we just want to keep it lively. And I think John's up next for his baptism of fire with the Death of Stars, I think, isn't it, John, next time?
Yeah, that's the topic.
Yeah, so don't worry, the kids are kind. So.
I'm not worried.
Yeah. God, yeah. Has anybody got any images to share at all? Anybody's got anything to hand? Any other astro gossip? No, I know Sarah's been active. Who was that, Emma?
It's all a bit quiet, isn't it?
Yeah.
Unless we're waiting for that rocket to come down, or is it already come down?
No, it's on the launch pad for a launch later this evening in the next few hours. There still no actual countdown time launch at the moment, but proceedings are happening, and they are thinking that it will go ahead this evening. So it could be anything up to perhaps 1 o'clock tomorrow morning our time, because they're about 6 hours behind. So the window for their last launch is about 6 p.m. their time, and they're 6 hours behind in Texas.
Are you referring to the one that Juno sort of re-entered?
10-15, which is the next generation of starships. Hopefully it won't do 2 launches when it comes back down.
There you go.
They need to get it right, otherwise they won't be able to get to the moon. Although they're still debating whether SpaceX are still going to be allowed to have the contract, because that's been debated again, isn't it?
I think they've told them to suspend any further work on it at the moment, haven't they?
Is this the two Elon and Jeff, having hissy fits about who's getting the contracts, and all the money talks and politics talks, and it all becomes rather messy.
He hasn't sold enough cars yet.
And of course, there's the old SLS in the background as well, I guess. Is that was it Boeing? Boeing hasn't really done a lot at the moment, is it? It's trying hard, and but
I think the problem was Boeing for years was an automatic recipient of a lot of the US budget, just purely out of tradition. And now we've had the last few years with, as you say, Bezos and Musk and a few of the others, they're not so favoured anymore, and I think that's their problem.
Boeing was all a military supplier, wasn't it?
Yeah.
So that made a difference to who they knew in the government, I guess.
I think Boeing might be trying to save their coffers for the litigation resolving from their 783 aircraft.
Oh yeah,
that are still grounded.
I'm just trying to think. I haven't read it yet, but I get this get aerospace, and they've got all about the spaceports in there, the UK ones, and that's the latest thing we're getting involved in, isn't it?
Because they're going to be building one in Cornwall, aren't they?
Yeah, and Scotland have got one.
Scotland, yeah, Scotland.
Yeah, unless they break away from us. But it's yeah, I have to read it because it's the space special, and it's all about we're getting involved in rockets. We've got a little part about the satellite things and how we're going to get involved. Ooh. So yeah, that's how, because we can launch loads of satellites from where we are. It's quite good where we are. So yeah, so
yeah, that's what
I'll
we
let you
need.
know.
Some more low Earth orbit satellites. Yeah, some more constellations up there.
Or space junk. No, that's
Yeah.
Oh,
I don't know if
Liz is having to go. So, see you later.
Liz had to go.
Oh, see you, Liz.
Yeah.
Bye.
Yeah. See you next time.
You're right. It is Cornwall. They've got one in Hebrides. They've got 7 ones. One in Kintyre. One in Wales. Yeah, there's 7 ports all around
Really?
British Isles.
Okay.
Sunderland.
You wouldn't think the British Isles is big enough, would you? Really?
Shetland. They're just going to put them everywhere.
Perhaps they should.
In case they overshoot, they could have got another runway somewhere else to land.
Maplin Sands. Bring back Maplin Sands. That was going to be the 3rd London airport at once. Perhaps they should resurrect that as an idea. Well, what? Yeah.
That was Boris's foul nest, wasn't it?
Yeah.
Oh, that's on. Yeah. Yeah.
Too many birds.
Yeah.
Yeah.
Yeah. So.
Yeah.
Would spoil wave creating stairs, wouldn't it?
Well, yeah. I don't know. I let me just share this whilst you're talking. Whilst you got onto that subject.
I think Sipson's available.
That's a very ugly picture, but it's just a very short image of standing on Wakering stairs.
Yeah.
And looking out. That's looking out due east towards Foulness, actually.
A lot brighter than we went. Remember?
Well, the moon was just below the horizon at this stage. And plus there are these 2 lights there that we didn't really notice so much.
No.
Bill, are you still on, Bill?
He might have gone.
See
there?
Yeah.
No, he's still on. He's muted.
Still on.
Though.
Oh, perhaps he's
He's on mute. He's muted.
Oh, okay. Okay.
So what lights are they? Are they South End going down, or
No, this is looking east. The red lights.
Oh, you're beyond
down,
South End.
the red lights down on the right-hand side is either Herne Bay or Whitstable,
Right.
Or it might be the lights in the middle might be Whitstable, actually. But you can see just the haze from the moon, and it was quite cloudy behind us, and the cloud is just starting to drift over on the right hand side as well. So it's not a great image, but it was a little experiment, a little foray. We sort of couldn't resist, but
what was the exposure time on that?
Oh crikey, I think this was about 30 seconds. Yeah, 30 seconds, and it was getting saturated with all of the background light.
Yeah.
And there's a bit of star trailing as well, even though it was a wide angle lens. Bill had a good one. Oh, has he gone now?
No, he's still here.
He's still here. Oh, there he is. Have you got yours, Bill?
Probably, but I don't know if I can share it on my phone.
Well, hang on. Let's stop sharing. But we've in contact with somebody else that lives over just the other side of Burnham, actually, just the other side of the Crouch. So, and he's sort of saying the potential for dark skies over there is pretty good. He's actually the president of the East Essex Astronomical Society, a guy called John Press. He's based over there. As fairly small club, but we've collaborated with them. They've come onto some of our meetings. But he's saying that it can get quite dark, so it may be a future potential location for us. It's about an hour's drive out from Upminster. So if you live over that side, then probably more like 40 minutes or so. Particularly, for Basildon and Langdon and places like that, it's probably.
I still wonder. There's about Wallasey Island actually.
Yeah. Yeah, I think the difficulty there, because I did investigate that one, I rang up the RSPB at Wallasey Island, and they said, "Oh, we've already got. There's another club. I think it's Castle Point uses it." And they said, "Oh, perhaps you can talk to them." And I thought, it's like gold dust, these dark skies, dark sites. So it might be worth another try. Actually, you never know. You never know. But where's Bill? You still looking for it?
I found it. I don't know if I can share the screen on my mobile.
Yeah. Let me pass you the ball. See if you can. You're a bit quiet, actually, Bill.
Yeah.
I don't know. I can't hear a word of it, but it looks funny. No. Yes, I can.
Oh.
Hang on. Has he gone? Oh, he's still there, is he?
Yeah, there we go. Oh, yeah. Yes.
Wow. Oh, there you go.
It's quite
much
clean,
better.
that.
Much better.
Yeah.
Yeah, I mean that was I don't know if you can hear me. That was that second exposure, and I stretched it a lot.
Yeah. It's you've got the lovely colour there, though, haven't you? The background, well controlled. So, but it shows the potential of the area, doesn't it, Bill?
As well.
I can hardly hear you, Bill. Sorry.
So where's that area that Martin Gill and Chris Smart used to go to? Was it Blackington, was it? Or?
It's
Latchington.
Latchington, yeah.
Yeah.
Let's have a quick.
That's out of Essex somewhere, isn't it?
It's out.
Yeah, it is.
It's actually, it's a bit further out from the other side of Burnham, I think, isn't it?
Yeah.
It is. Yeah.
Yeah. As you go to Burnham Crouch.
Yeah. Let's see if I can just grab that ball back again. Hang on. Where's it gone? Hang on. Because it might be worth just doing a quick poll for people that are on this call right now. How far you'd be prepared to travel. Let me just share the screen.
I think you'll count me out.
Yeah, but you're already blessed, Roger, down there. So,
I suppose I am.
So just for Roger's purposes. Let's just zoom right out. You're over here somewhere in a nice dark sky.
Yeah.
And we're there's London.
I know exactly where you are.
We're all going to Rogers instead.
Yeah.
Welcome.
You get a mini bus to him.
Yeah, why not?
Where Bill and I were the other day or the other night was down here. There's Great Wakering.
Yeah. All right.
And there's Wakering Stairs. So if I just zoom out a bit, we were right sort of there. Oh. Yeah. And I think the lights that we were seeing were like Herne Bay or maybe even Margate. Could have been, or Whitstable. There's Foulness Island. But Foulness is, there are people living on it, and they are the only people that have the right of way to get across there. You have to have a special permit because it's all Ministry of Defence land.
Yeah,
A lot of it.
You can go over there on trips, but I don't know about night time.
All of this sort of round here. We did try and take a little drive down some lanes, didn't we, Phil? And got to locked gates and all sorts of things, and signs saying "Do not pick up dodgy objects on the ground; they might explode." But Great Wake, it's not too bad, but actually where Preston Martin would go to is Latchington, which is here, or somewhere there. I've got no idea where it is, but it was out in that region. But the guy we were talking to, he lives in Burnham, and he was basically saying this whole sort of Genghis National Nature Reserve over here. You've got all these lanes into the middle of nowhere, and the skies are really quite dark there.
Yeah.
So,
what about Hanningfield Reservoir? I believe some people have been.
Hanningfield is there. But you've got Billericay, you've got Wickford, Southwood and Ferrers, and Chelmsford all around it. So and of course, directly south you've got Basildon, and over to the southeast you've got Southend. So I don't think. And if you go to Hanningfield, there are car parks, but there's trees all the way around it. So,
I went with a friend of mine. We went a couple of times. I can't remember now, but it's a dinghy, and it's on the estuary. You look out, but it's actually at a place where it's a nature reserve, a bit like Clifton Park. So maybe there might be one we can get hold of.
There's Wallasey Island.
Allow you on site, and because it's near the water, you see a lot of sky.
Yeah.
You can actually get right to the water's edge on the Dengie Peninsula.
Yeah, that's what I'm thinking.
Which end, Clive? Because the Den is right. It's quite
right in the middle. There is, if you zoom in, you can see the roads there. But there's some of the roads go right up to the water's edge. Towards the northern part of the peninsula. So, well, there you go.
Is that near Bradwell?
Yeah. Not far south from Bradwell. There you go. Look where the fields go right up to the foreshore.
Yeah, because you can go up to the chapel and you just see all over the sea, don't you?
All right. But is it? And it's open all the time, is it? It's not restricted.
When I was there, I was looking for murmurations, birds, etc., and there was no gates across the road. You drive down a road which I think cuts right through the farmers' fields.
Yeah.
Right.
As far as I could tell, it was just a public road.
Yeah. Well, that looks ideal. It looks ideal, doesn't it? Yeah.
There's a little village you can go up to. Is it Peters in the Wall or something like that? And you can go through the village and park your car.
Where was that church?
That's the one on the old chapel.
Peter in the Wall. Yeah.
Peter in the Wall. Yeah. You can walk right along that up to Bradwell.
And again, that's just south of Bradwell, isn't it?
Yeah.
Bradwell's a bit further out there.
Above, over the.
It's round the corner.
Yeah, round the corner, whatever.
Oh look, there's the airfield.
They've got public walk paths there, so you can go up there and walk around.
Is there a power? Is the old power station still the nuclear?
Yeah, it's still there.
It's part of the decommission, isn't it?
I think the Chinese were going to redo it up.
Oh, we'll steer clear of that one then.
So they could grow their mustn't say it, must I?
I don't know if you folks remember, we used to have a member called Dennis something or other who used to live in Hornchurch, and he got very frustrated by the industrial estate at the bottom of his garden with security lights, that he sold his house and moved to somewhere near Harwich.
Yeah.
And I don't know if anybody remembers him, but or if anybody's still in contact with him. But further along the coast, north of this part that we're looking at, is appreciably darker than sort of the southeast London area.
Harwich is right up here. Of course, you got Felixstowe and you know the big port there. So, but I suppose anywhere that you're a little bit further. Was Dennis? Was he the fairly big guy, wasn't he?
No, he was a little older, sort of my age, but he used to wear quite big glasses. One of his issues was that he had a hearing problem.
Right.
But he moved, I don't know, 15 years ago, 10, 15 years ago.
Right, okay.
So, I mean, I don't know whether many people who are members at the moment remember him.
No. I know Nick's outside Colchester now, isn't he? I think sort of
He's
up that way. So
can you zoom into Colchester?
what's this magic mystery tour?
Yeah, it is actually.
There we go.
Right. Just at 11 o'clock, you see the word Wormingford.
Yeah.
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 Okay. It's quite a dark site there.
Yeah.
If you stop, move your pointer south. No, now move it west.
Yeah.
A little bit more. There. Stop there. Stop. No, stop there. Yeah.
Bernie the Bolt.
Bernie the Bolt. Yeah. There's an airfield there.
Oh. I think that's near where Nick is somewhere.
There you go. Essex and Suffolk Gliding Club.
That's right.
There we go.
And you see the line, the track, which is going from right to left. All of that bit there is well, it's not their land, but they rent the land.
Ah, right. Oh, that's worth knowing. That's there.
And if you go further along, so I zoom in again.
Yeah.
Right, stop there. Now, track to our left.
Yeah.
Bit more. It is a bit like Mystery Tour, isn't it?
Yeah.
More. Right, stop there.
Yeah, go on.
No, stop. Now move your pointer to the left by about an inch.
An inch? I only do metric.
Oh, sorry, beg your pardon.
At the end of that field.
Which
2.5 centimetres. Thank you. Now up a bit.
2.4 actually.
Right, now 10 centimetres to the left. This will be workable, trust me. Right, no, go back. No, too far. Slow down, Les.
So impetuous.
Just give me the coordinates.
I don't have the coordinates, but there's a gentleman there with a large house, and he has his own observatory.
All right.
There.
Not Nick.
Centre of the picture.
Oh yeah, I can see a white dome.
There we go.
Yeah.
Is that next to the railway line?
Yeah.
Oh.
Yeah. That one there. Is that a water tower or something? Or is that a dome?
There is a water tower there, yeah. No, if you come, not. No, you've come out again now.
Well, I'm just going to try and see if I can see it. Hang on.
I don't know whether you can see it from the road, actually.
Where were we? I forget where we are now. Wormingford. There we are, down there.
Yeah.
Down there. There you go.
Right, down on the just to your left. That's the actual dome, not the one you highlighted.
That.
No, down.
There.
There.
All right. Okay. Okay, well, let's take a look. See, shall we?
Ooh.
That's an 8.
Let's have a sneaky look. No, nothing there. He's hidden it well.
He's
Hang
hidden
on.
it well, yeah.
Sometimes these maps are about 2 years old, so it could be.
Got
This one was
2021.
no,
Oh,
May
2009.
29.
Yeah.
Yeah. Oh well.
Oh,
Never
so-
mind. Never mind. Ah, so good little insider knowledge there, Clive. So you're our man on the spot. So I think you've got the action point to come up and find a nice dark sky for us. But seriously, folks, what would be useful is for those on the call, we can do this at a club meeting. Is just to know how many would be willing to do the trek out. Unfortunately, it's not something we can always plan too far ahead because, like Bill and I the other night, it was a case of sort of, just a few hours earlier making it's a possibility, and then we put the notice out on WhatsApp just to see if anyone else is interested. But of course, you can't always just drop everything and go on. But if you want to let us know via WhatsApp or an email, and then the original idea of the WhatsApp was to alert people that we were considering popping out somewhere for an observing evening.
Yeah.
And very often, perhaps at short notice, or at least to say if we've got it planned, then we might have to cancel at short notice. But if folks are willing to travel that bit further to a better dark site, then I'm sure we can see what we can get arranged, and put the Google Map coordinates there, and fingers crossed everybody can get out there. And even if it's just a case of bringing along some binoculars or something.
It takes about 50 minutes to get there. On Billericay, that is.
Yeah. Well, do you know the guy personally, Clive?
No, I'm a member of the Essex and Suffolk Gliding Club.
Okay.
Sorry about that.
No, that's all right.
She's gliding over it.
Had you dropped in on there a couple of times?
No. I've overflown him quite a few times.
I'll have a word with my dad. He does metal detecting, and so he knows quite a few farmers. So I'll have a word with him, see if he knows anyone that's got some dark farms that we can maybe pitch up on.
Oh,
The thing is parking.
Yeah. They usually go on big club gigs at the farm, so it shouldn't be an issue.
Yeah. Farmers don't like you driving over their fields.
Yeah, no, they certainly don't like that.
No, I think that's what I'm pretty sure that's what Martin and Chris did. They found a friendly farmer who would allow them to, just park on a bit of land, perhaps a bit of hard standing. I don't know. And if we can find somewhere like that, I'm sure.
You can see the airfield from that shot there. How big it is.
Yeah.
There's a place up towards Lowestoft. I know it's a bit far out, but it's actually directly on the 812, about 20 miles short of Lowestoft. It's a place called Haw Farm, HAW Farm. It's actually a registered dark site, and it's a campsite there.
Yes.
And twice a year they actually have star parties.
Yeah. I think you mentioned that before, didn't you, Milne? Where you
Yeah, I've been up there. It's good. Yeah. It's
of course
just how dark the skies were.
There's 2 sites near there, isn't there?
Yeah. There's another one north of where you are now, right up there by the water.
Yeah, Kelling.
There. Yeah, that's another dark site.
Yeah.
There's actually a group that actually are up in that area. I forget who they actually are, but they actually have 2 observatories up in that area.
All right.
Wow.
I'm trying to find where they are. Kelling. Yeah, Kelling Heath. It's right up here somewhere.
Up in it.
Yeah.
It's a bit to your right, Les.
Is it over there?
Yeah, just
Oh yeah, right on the border.
right on the edge.
There's Kelling.
Yeah.
Yeah.
Not far from Cly.
Who? What? Yeah, he does, doesn't he?
Yeah.
Sorry.
I know, trying to think where they are now. Up here somewhere. That's where Alto Astro are. Little village. If you ever wanted to know where they were, up here somewhere. Aylsham, I think it is. There it is. Altair Astro are in a little road down here somewhere. Probably there we go. Altair Astro. If you've ever bought any stuff from them, you're actually buying it from a little place down here somewhere.
Get yourself a cloudy at the same time.
It's good, isn't it? There we go. Is that it? There they are. Altair Astro. That's Altair Astro. For those of you, and if you've ever tried to get in contact with them, it's a nightmare because I went up there once on a short break, and the shop, I went past there 2 or 3 times. The shop was never open. I think they just use it as a warehouse.
You're not supposed to do 90 down that road.
No. Anyway, there we go.
Ultra Astro.
There we go.
I use one of their cameras on my photography.
Yeah, they seem to do quite well, I think.
They got quite a good reputation for being prompt sending the stuff out. That's providing they got the stuff to start with.
Yeah. I don't know what their after sales service is like, John.
Pretty crap in my experience.
Yeah.
All right.
So yeah. Okay. Cheers, Brian.
Yeah. Bye bye.
See you next time.
Good night.
But yeah, what I would say is, just ping us either on WhatsApp or I mean, I'm happy to post my. Hang on. Can I do it in chat? Do we have a chat on here? Yes, we do, don't we? I'm going to stop sharing. Hang on. I'm quite happy to let everybody know my email. Just ping us if you haven't got my email or you're not on WhatsApp, and if you want to go on WhatsApp, then just send me an email with your mobile phone number. I'll get you added, and that way we can. I think everybody on here that I can see is probably on there who wants to be on there.
No, sorry, Dennis.
Well, let's say do you want to be on it, Clive?
No, thank you.
Right, so everybody that's on there who wants to be on there, you know.
I'll send you or Liz an email.
Perfect. That would be brilliant. Yeah, really appreciate that.
I need to ask.
Yeah. Well, I think we have to sort of try these things and see what happens. And I'll speak to John Press over at Burnham and see if he's got any suggestions as well.
Right.
Oh, the other suggestion was Cressing Temple. For those of you that know, a few of us a couple of years ago did a country show up there. Took our gear. We shared some time with North Essex Astro. I think it was Andrew and Emma, Liz, Mill. I'm not sure if Mill was there at that time. Yeah, I think you were, Mill.
Yeah, Mill was there.
Essex show one, isn't it?
Yeah, we did the South Weald one, and then there was one at Cressing Temple. I'll just share that.
And me.
Yeah.
Oh yeah, and you.
Oh yeah.
Cressing Temple is
Braintree way, isn't it?
Yeah, I'm just trying to find it. It's
Beyond
up
Whittam.
Yeah.
Beyond.
Well, whatever. Go up.
Beyond.
Somewhere beyond Whittam.
Yeah, it's actually right in between Whittam and Braintree. There's Cressing. and there are, if I can find it, can you see where it says Barnes?
Cressing Temple Barnes, where is it?
It'll be on here somewhere. Hang on.
Up and left a little bit.
Temple Barnes. There we go.
Oh,
Down and right.
Down and right.
There we go. And what they've got here, if you can sort of see where it is. Okay, it's still fairly near Whittam, but actually it's Essex. It's actually run by Essex Country Parks, and we're very good friends with them at South Weald. And I was in contact with the. They operate the country parks out of their offices here, and they've got this wonderful sort of parking area. It occurred to me that we could just drive up there, but they said the gates are sort of locked. I think there's a gate there by the looks of it, or wherever it is. But that's another option that we need to try out at some point. It's probably about a 45-minute journey from Upminster.
Yeah, it's a bit quicker, isn't it? Because you can go straight up the A12.
Yeah. You can see where it is in the.
Go through Whittam.
There we go. And if I did it, directions here. Where am I? That's where I live.
It's quite easy to get to. My friend used to live in Silver End, which is literally the end of that road.
Oh, right.
All right. There's a pottery near there. Brick Lane, brick house pottery. Ceramics.
There we go. 40.
That's good.
Once you're on the A12, it's pretty quick up there. So. But anyway, they're all possibilities. Possibilities. But, yeah, all possibilities. And then, of course, these great plans come to naught when it's cloudy. So nobody buy anything, especially you, Sarah.
Yeah,
You're buying too much recently.
I haven't bought anything yet. I'm just window shopping.
I'm still waiting to see what everyone else has got.
I know what photos I want to get. It's just knowing what equipment to buy to get those photos. So, yeah.
Exactly.
Yeah.
It's good.
What do you want to know, Kai?
Well, and until what to do, what bit of kit to buy. And I think, as it's been expressed previously, when we have a meet together, I can look over shoulders and ask all sorts of infuriating questions. Then I'm better equipped to make my own choice.
Yeah.
Yeah.
Yeah. Yeah. I mean, my house quite different sort of stuff. So it's similar, but we have completely different styles. Companies terms of company. Size of sensors and stuff. Just the case that
Sorry, Bill, you're breaking up.
Dropping out, mate.
Lucky you.
Yeah.
Yeah, I waited this long, so I'm going to carry on waiting, and be happy with what I purchased and make the best use of it. So,
Clive, do you have a clear idea about what sort of thing you want to do, though?
Well,
a bit like Sarah's saying, you need to have some sort of idea about what you want to try and achieve.
yeah, we've had this conversation, John, and I'm firming up on it. But then someone comes up with an image, and I think, oh, isn't that terrific? I think, oh.
Yeah, but that means Les has produced it based on hours and hours and hours and 14 cycles through different sets of kit and something that costs about £8,000.
Well, I remember Les was saying, oh, I took this with an 80mm whatever, with this filter and that filter and this filter and that, and I thought, oh my God, It seemed like he had more filters than telescopes.
It depends what sky you got as well. If you got a good sky, you get good images. You got a crap sky, you get crap images.
Yes, very true.
Skies around here ain't very good.
Clive, you've got a DSLR, have you? Have you got a digital camera?
I have.
And have you got a what lens have you got for it?
I can go from 600 to 24 mil.
So you got a 600 mil zoom on it, have you?
I can do, yeah.
Let me just show you something.
Never mind a telescope. I'll just use that.
Star Trek and use that.
Yeah.
I've got an aged Nikon, but it's a bit short on pixels. But I've just acquired an Olympus, which is a bit better.
Let me just share this, Clive, and it might give you some. Hopefully, it might inspire you, or not. This is for those. It might just come over all mushy, but actually, what you've got here is two galaxies, M81,
right,
and M82. That's Bode's galaxy and the Cigar galaxy.
That's what I got as my background behind me.
Yeah, there you go. There you go. But Clive, this was shot using my digital camera with a 210mm lens, and it was a bunch of 2-second exposures on a fixed tripod.
Right.
So it's basically okay. It's nothing like Roger's backdrop, but on the other hand, it shows you what you could. And this was from my back garden in light polluted Upminster. You can sort of just about start to, get stuff out. And Sarah, I think you were doing the same thing before you got your Skywatcher, weren't you? You had your digital camera, you had your lens, and you just pointed up at the sky. And that was in where are you?
Romford.
In Romford. So
right, yeah.
So you could, if you're interested in the photography side of it, there's nothing to stop you starting with what you've got now without even buying a telescope.
Yeah, my first image of Andromeda was with a 14mm in Norfolk, and it was so minute, but I was stoked that I got it.
If you've got if you've got a clear digital image, of course, you can always blow it up.
Yeah.
I've taken shots of the Milky Way at sort of like 3:30 in the morning, and got that quite nice. But yeah. But yes, I can see the background behind Roger now. I can.
Yeah. That was with a 5-inch refractor at about 970mm focal length. So
right,
you're not that much further away from a 600.
600, yeah.
I think John, the question was deep sky or near, wasn't it? What do you want to look at?
So most people sort of tend to either split between planetary type work, they want to try and get pictures of Jupiter and Saturn and Mars, or they want to do mostly deep sky stuff of the sort we've just been talking about.
Yeah. I think I might be.
They're only 600mm focal length, aren't they?
Sorry?
Mine's only a 600mm focal length for my scope, and I still get images. And if you've got that camera with that lens, you should get the same, because you can crop the image.
Things like Orion, wouldn't you, easily?
Oh, Ryan, you can get it too. Also, maybe you have to pick up.
Andromeda should be fine in that.
Yeah.
Andromeda will fill the frame, I think.
Yeah.
Yeah.
Okay. I'll dig out the old Nikon.
I mean, I've used an old Nikon full frame D700, which is only 12 million pixels. I got some fantastic night shots with it.
Yeah.
Just using a DSLR camera and lens.
Yeah.
Well, it doesn't use all the pixels, does it? It only uses a certain amount of pixels. You could have 20 million pixels on a camera, but you don't use 12 million the way the photons hit the sensor.
Yeah.
So you'll
So
still
it
get
depends on the size of the the size of the pixels, obviously, as well.
Yeah.
Because the 12 million pixel on a full size frame is bigger size pixels than some of the camera sensors that you get nowadays. So you can
you can always bin it, can't you? Make it bigger in 2x2 bin, and you get double the width of the sensor.
Yeah, I think that's it. If you've got a full frame, and my Nikon's not, but if you've got a full frame, you've got bigger pixels, and then you've got a better light capturing capability then, and that's the critical thing.
Yeah, because some of the more professional mono cameras, some of them have got like 9 or 12 micron size pixels, where upon most of the other cameras are like only 2 or 3 microns in size. So consequently, you don't get as much clarity, and you get a lot of noise with it as well. So you know, depending on what the focal length of the telescope is, what you want to image, and all the rest of it, you've got all these calculations.
Yes, it's not necessarily the length of the lens, is what you can do with the pixels afterwards.
Yeah, you got to.
That's the other side of the coin, isn't it? You know.
And I think that's where I'm struggling with my processing. I'm not sure how far to go with it. So
go as far as to a stars bloke.
My best friend with that.
Just go as far as to your stars start blowing out. And once they start changing, then you've gone too far.
Yeah, true.
Thank you, folks.
Cameras. Where did you get them modified?
What? Modified for what?
So you've got a digital camera, modified for astrophotography.
If you're asking, I don't know if Bill's dropped, but I know Bill. Both Bill and I, we modified our cameras ourselves, just following some instructions. You sort of have to take a deep breath and wave bye-bye to any warranty and you know, anything like that. But you know, and be handy. Yeah, you just have to be careful. But there are companies out there that will do it for you. But to be honest with you, it will help the sensitivity on deep sky stuff. Because it just allows more of the long wavelength light to hit the sensor, the you know, closer to the infrared, where a lot of the nebulosity is. But to be honest with you, unless you, I would, with hindsight, having done it, I still ended up going out and getting a dedicated astro camera, and doing it that way. Because the benefit of a dedicated astro camera is it's dedicated. It's not an all-purpose thing. Of course, you know, it does cost, so that's not something for everyone. But you know, if you do it to your DSLR and you wanted to use your DSLR for sort of daytime shooting and stuff, you've then got to put, you know, a filter back in to cut the ultraviolet and infrared and redress the balance that you've taken out by removing the filter in the first place. So you know, what you get with one hand, you have to take away with the other, sort of thing.
Is this the anti-aliasing filter you take out?
This infrared filter you take out, UV.
IR cut filter.
Oh, the IR, right.
Yeah, it stops the red channel coming in. You need the red channel for the sky, so it blocks the red.
Right.
Some digital cameras are more prone to getting red. They will pick up more some of the red, but not if they're modified. They get more of the red.
Yeah.
But the extra-terrestrial cameras, the ones you buy, like 183C I've got, lets all the red channel and everything through. So they don't block any channels out. So
I got a 183C.
Yeah, I've got one. I've got mine refurbished though. Not refurbished. They give it to me ex-demo. You get them cheaper.
Oh right.
So if you ring Extra-terrestrial, say to you, if you want an ex-demo one, they will offer you a cheaper version of it. So I think I paid £300 for my one. So
that's good.
They retail at 500. So
I know. I bought one at the Practical Astronomy show up at Kettering a few years back. I didn't know what I was buying really. I just sort of grabbed that one.
if you want to go the ex-demo ones, then you get a cheaper price. You only get a year's warranty, but they're about £200 cheaper.
So perhaps what we should do for you, Clive and Sarah, is we go and demo a few cameras and then tell you we've demoed, and then you can ring up the next day.
I won the other month for £400. So.
Which retailer is that, Andy?
Ultra-terrestrial.
Ultra-terrestrial.
Yeah, I emailed them, said you got any ex-demo ones, and they come back saying they've had this mono one for 400, but it's a 183M, which is 635 to buy. So they're not £200 off the price of each camera. So, and they're tech ones as well available. So.
Right. I'm content with waiting and biding me time. You know. I think that's the way, rather than just throwing money at it. Because then then what do you do with it? It just goes in the loft, doesn't it?
They bring out different sensors all the time. They bring out new cameras all the time, so they've all got different sensor formats. They're all made by Sony, but they're all different big the chip sizes. So they'll do different things. So
that's right. Yeah.
I mean, some people brought 269Cs, 26Cs, and they brought out 533 now, which is half the price. It does just as good a job.
Well, it's like a lot of things. They're making so many advances on them now that it's going to come to the stage where do you wait for the next evolution and do nothing, or do you bite the bullet and go in and use it and do what you want to do?
Latest one is a 61 million pixel camera, which is $3,500.
Yeah. Do you go black and white or colour?
That's the question, isn't it?
Yeah.
I think if you go colour, at least you've got the colour to manipulate.
Yeah.
Because you can always go to black and white later on.
Yeah. If you go colour, you're only getting a quarter of the light onto the chip.
Yeah.
You get a quarter of the red, half the green, and a quarter of the blue. Because of the Bayer effect. It's RGB in each of the pixels, you see. So if you use a mono, you can use all the pixels. You just either use a red or a green or a blue filter and then merge them all together after. And you're supposed to get much better results.
Yep.
Especially it's mono in light pollution skies, isn't it, really?
And then you've got your hydrogen alpha, and then you've got your sulfur, and then your oxygen filter, so you can do Hubble palette colours with the mono camera as well. It just goes on and on and on.
Yes.
Spend loads of money.
It depends on what you want to photograph, whether you want to do planetary stuff, lunar stuff, solar stuff, or nebula. It depends on what you want to do. Then you know what sort of camera, whether you want it colour or black and white, and then working at what telescope you need for the pixel size comparisons.
I think I'm leaning towards planetary. And you, Sarah?
I think I'm more galaxy.
Galaxy.
Yeah. Yeah, my very first image I ever wanted to get was Andromeda. You know, and getting that on my Evo, I've got a long way to go, and I need to perfect it. So I'm hooked on that. I only obviously get a certain amount of that on my sky because I've got a big building one side of me, and then I've got London the other side. So I need to get out into darker skies.
Yeah.
Well, Les was saying he's tried it from his back garden, but I can't get anything from my back garden. I'm surrounded by trees.
Yeah, it's frustrating. Even for me, because I've got
Sounds like you need an
such a
axe.
nice area in front of me.
I've got a chainsaw, but the trees aren't on my property.
Just go next door and cut them then.
Well, I mean that's the thing. I mean, whatever we do, I think that from my experience, there's always going to be a compromise somewhere. And if you want a color camera, then you're not probably going to get as good results with dedicated mono. But then if you have a mono, you've got to have the filters, and if you've got the filters, then you've got to decide what filters, and you've got all of that. With color cameras, you can get special filters that will give you the effect of narrowband and be able to isolate the different narrowband wavelengths. So that's something to consider with color cameras. If you want to do planetary, then you can get away with sort of fairly cameras that have got, smaller chip size and so on. But you need very high frame rate depending on how you're going to image. And of course, with planetary, you need a much longer focal length.
Yeah.
And if you want the detail, so that's for your magnification. But if you want the details, the surface details, you need big aperture as well, because you won't resolve the details. So if you want to specialize in planetary, like Damien Peach, for example, who's like, we are not worthy. He I mean, not only has he got the right gear, C14, a 14-inch diameter, I don't know, what is it, about a 3-meter focal length?
Round about that, yeah.
Is it on the Razor?
Oh, is it the Razor? I don't know what.
No, it's just the 14-inch Celestron.
Yeah.
They don't do a 14-inch Razor.
No, they don't.
But he'll
that won't be long enough for him.
But then to do planetary, you've then got to think much more about the seeing conditions, and and find he gets all his best images by going to the Bahamas.
Yeah.
Or use a telescope.
Or
I'll take one for the team. I'll go there for you.
We go to Virgin Island, go to Mr. Bishop Branson. You've got his own island.
But I think that, Les, you made a very important point here in meeting Clive's particular requirement. You need a completely different scope set up to what you're going to do for deep sky. There's his point about needing a much more focal length and possibly even adding in additional bits of kit like Barlows and stuff like that, just to get the magnification.
Yeah.
And then we've not even discussed mounts. That's my thing at the moment, is I really want a go-to mount because I haven't got a clue where I'm looking in the sky.
Yeah.
It certainly saves some wasted time, in my opinion.
Yeah.
You said that before, John. Yeah. All taken in.
Yeah.
But yeah.
And I think the other thing is, once you make your decision and you make your purchase, and then you start to use it, because let's hope it doesn't just go up in the loft and you're out there using it, and then you get hooked, and then you decide, actually, I want to do
yeah, actually I want to do galaxies.
Yeah.
And so on. So I don't think there is a I don't know, I could be wrong, but is there a compromise telescope size? Is there a compromise mount? Or you'll never be happy,
Yeah,
that's 3, Roger.
I've got 3. Now the funny thing is, I set myself a budget, and the first telescope I bought was a C11. Since then, I've gone from a C11, which I've still got. I've got a 5-inch, and now I've gone down to a 71mm. I'm going in the opposite way. But the 71mm William Optics I got is brilliant. It's just a small triplet, and I got some fantastic pictures of the moon with that. Absolutely amazing, and Andromeda is absolutely awesome.
Yeah.
And obviously, because you've just got a small size telescope, you don't have to be too much of a problem with your tracking, because you you've got that much wide field, which is absolutely nightmare if you're using something for imaging Mars or Jupiter or Saturn, where you've got the focal length and magnification to take into consideration.
Yeah, yeah.
The longer focal length, less time you get on the object, so it goes out of view faster. So.
There's
tracking.
Yeah, you got to have good tracking on polar alignment on your mount and everything.
Well, and the other thing to remember is that most of the guys who do planetary, they don't shoot single shots. They tend to shoot video.
Yeah.
Right, and then stack the video frames.
Yeah. I mean, I bought a new ASI 462 color camera last year because of the Mars opposition, and I was getting anything up to 136 frames per second on that, and that is absolutely amazing for stacking and then using in various programs to get the detail. But as you say, you need the resolution with a larger aperture to pick out all the detail on the surface.
Exactly.
What compromise do you want to go for?
Yeah.
Plus, it's a turbulence in the atmosphere, so you've got to get through that as well.
And then you need an atmospheric dispersion corrector for the altitude of where the planet is.
I think that's enough of this, because my wife's in the room listening to all this, and she's got a pen out and adding it up.
Say $5 grand in your budget, and you'll be all right.
Let's hope we can get together at some point in the not too distant future. We're getting to the point where it's lighter evenings, of course, so it's not ideal, but we'll see if we can work something out. Even if it's to do some Milky Way stuff where you can just bring along your camera on a tripod.
Yeah.
And
that's what I'm doing tomorrow night. So I might post some up on the Facebook website.
Yeah, please do, Roger. Yeah, brilliant.
Okay. Did you all see the picture I did of the moon by Glastonbury tour?
Yeah.
Did you not play a flute up there?
Yeah.
They play music.
Fortunately, I didn't have a long enough telephoto lens on my camera, so I used my telescope. So that was
That's
quite
the
good.
other thing, you see. I mean, if you haven't got a lens on your camera, you can attach your camera to the telescope.
Yeah.
Which is, I mean, I know people that have done fantastic pictures and they use their blooming phone.
Yeah, I've seen pictures with up to a Dob or a telescope with the iPhone, and it come out absolutely amazing.
Yeah, all my moon shots are with my mobile phone attached to my telescope.
There you go.
It's great for things like that because the moon's so bright. You can use a short exposure, get away with quite a lot of stuff for that.
Yeah, brilliant.
Right.
Well, look, listen, folks. I mean, we're a half past. We've had a great evening tonight. We've had a brilliant talk and some good banter as well. So let's hear more of this in whenever our next meeting is. A couple of weeks time.
Couple of weeks time. Yeah.
And keep the channels open. Let's hear of your experiences, and if we sort out anything, we'll let you know via WhatsApp or email, whatever. But it may be like a last minute, depending on the vagaries of the weather and all that sort of thing. So,
I'll wind you all up with my bottle 4 skies down here.
Yeah, we're going to mute you now, Roger. Going to mute you. Sorry. Yeah.
Right. Good night, all.
All right. Good night, everyone.
Bye.
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 Bye. Bye.